Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Good. Last session, of course, we looked at the good old terrain draw area again, and I still don't know what to do about it. I was thinking that maybe we ask chat if he has some ideas. Maybe we just copy the snippet and just ask. I don't know, I don't expect much coming out of it, but I don't have any more ideas here. Given the following codes, C++ code snippet, is there any strategy to improve the accuracy of the approximation for centering a drawable, for centering the drawable area of the centering the area of the terrain of the within the terrain within the camera. It's in the camera view. The camera's view. So just say here, very fast approximation works perfectly. Top-down view, good enough for regular. All right, with ground view. If the visible terrain area is not large enough, can increase. It won't know that. Max. View deer, look at vector. I say look at vector is the vector from camera pivot to camera position to look at center. MX and MY describe refer to the drawable to integer distance to the visible size of the terrain that needs centering. XY factor is 10, and refers to the size of a terrain tile. 0. Let's say magic edgeLen is just a arbitrary value that works kind of okay. Kind of okay. That works, let's say, okay-ish. Okay-ish. Um, um, mm, mm. Camera pivot is the look at position, right? Let's see. Yeah, it's a look at position. Let's say camera pivot is the 3D look at position on the terrain. Is the 3D from camera position to look at position fit to the visible size of the terrain that needs centering. What is the tricky the main issue with this approximation is terrain elevation. When the top edge, when the terrain at the top edge of the camera is lower than the terrain at the look at position, then we can see much more terrain tiles than if the terrain was flat. Then we need to see more terrain tiles than if the terrain was flat. To see more terrain tiles at the top than if the terrain was flat. The top edge of the camera is lower. When the terrain at the top edge of the camera is lower than the terrain at the look at position, then we need to see more terrain tiles at the top. At the top edge. At the top edge, therefore the drawable area let's say new arc X and new arc Y refer to the top left edges and top left edge to the XY origin position for the drawable terrain area. The main issue comes with terrain elevation. When the terrain at the top edge of the camera is lower than the terrain at the look-at position, then we need to see more terrain tiles at the top edge, and therefore the drawable area, therefore the drawable terrain area needs to be centered differently than if the terrain was just flat. With Magic Edge Landscape, we can tweak this. We can tweak this. We can tweak this. We can tweak this center position. But it does not work well. Does not work perfectly accurate because it is just it's just a guess. What's yeah, I already asked this question. Good. Then let me send this and see what the AI comes up with. Maybe it has some brilliant idea. Yes, the core problem you're running into is that your current method is purely planar, XY based, while the visibility error is caused by height variation along the view array. Any constant scale, like Magic Edge Landscape, can only be correct for one terrain profile and one camera pitch. To improve accuracy without going fully brute force, you need to let terrain height influence where the visible edge actually lies. Below are progressively better strategies from cheap but better to accurate. Project the view frustum onto the terrain instead of guessing. Instead of shifting the pivot by a constant amount along view dir, compute where the camera frustum intersects the terrain and center based on that footprint. Idea: take the camera frustum corners, near or far plane. That's what the original code does. Cast rays from the camera through those corners, intersect each ray with a terrain height field. Compute the bounding box of the intersection points. Center the drawable area on that bounding box. This naturally accounts for terrain elevation, camera pitch, camera height, field of view. Why this fixes your issue: if the terrain is lower at the top edge, the ray hits further away, the footprint expands. Yeah, that's what the original does. 4 rays are usually enough. Height aware correction using average edge heights. Cheap improvement. If full ray terrain intersection feels too expensive or complex, you can improve your existing approximation by estimating height differences along the view direction. Along the view direction. Strategy: sample terrain height at camera pivot, a point forward along view dir at some distance. Aha. Compute height delta. Aha, okay, that's actually not a bad idea. Yeah, so insert. So the problem with this one here, with the view frustum intersection on the terrain, as we already know, has a problem that if the view frustum, if the view plane is not intersecting with the ground, then we can't get that intersection point, right? And then the whole thing falls apart. Height aware correction. Sample terrain height at camera pivot, a point forward along view dir at some distance. Compute height delta. Adjust the shift amount proportionally. I see. Example. Terrain height, height delta, H0. Tune the scale experimentally. Height bias. Why this helps? If the terrain slopes downward in the view direction, H1 smaller than H0, you push the drawable area farther forwards. I see. This won't be perfect, but it adapts dynamically instead of relying on a fixed magic number. Yeah. Compute the horizon intersection. Very effective for ground views. For ground level or low pitch cameras, a big error source is where the view ray grazes the terrain. The horizon strategy. Cast a ray from the camera along the view direction. Find the first intersection with terrain. Use that intersection distance to determine how far the visible region extends. This is cheaper than full frustum intersection and directly targets your worst case error. Compute the horizon intersection. For ground level or low pitch cameras, a big error source is where the view ray grazes the terrain, the horizon. Cast a ray from the camera along the view direction. Cast a ray from the camera. Find the first intersection. Use that intersection distance to determine how far the visible region extends. Use 4 frustum corner rays. Intersect against a coarse terrain lot or height map MIP. Cache results and update only when the camera moves. Near perfect centering, minimal runtime cost, no magic constants tied to pitch. Intersect against a coarse terrain lot. Cache results. I think this is what the original. That's what the original does. It uses the 4 frustum corners. It then does some sampling on the terrain. And it only updates when the camera moves significantly. Near perfect centering, minimal runtime cost, no magic constants. Non-linear depth variation. Yeah. Cheap improvements. Yeah, so this one, the camera frustum shit has a limitation. Has a limitation of the pitch. Height aware dynamic offset. This one sounds interesting. I haven't thought of that. It's this one here. Yeah. Feels too expensive. You can improve your existing approximation by estimating height differences along the view direction. we'll be right back. Okay, so estimating height differences along the view direction. Sample terrain height at camera pivot, a point forward along view deer at some distance. Compute height delta. Adjust the shift amount proportionally. Yeah. Tune the scale experimentally. Where this helps, if the terrain slopes downward in the view direction, if the terrain slopes downwards, you push the drawable area farther forward. That's a good idea, yeah. Now this still will require some fine tuning, but maybe it's good enough. Cheap improvement. Yeah. If the terrain is lower at the top edge, the ray hits farther away, the footprint expands automatically. Yeah. Height-aware correction. Okay. Probably want to sample multiple points, right? at the top. Dissect against the course, terrain lot, cache results. Ray height field intersection. So we do a let's say we sample a bunch of points. We sample a bunch of points. How do we know where to sample from exactly? Find X at Z. The problem is I don't know where to start sampling here, so that's already a problem. Frost and corner rays intersect against terrain lot. Cache results. Original code 0. Original code 1. Okay. Why do we not see it? Hey, I want to see this code, please. Update. Hello? Doesn't want to update. Do we need to restart Visual Studio? Thank you. Okay, so intersection Z. Section Z. Float min height. I can move this here. So the intersection Z. So I wonder if we maybe can do. Maybe what we can do here is we just say we make this a little bit cheaper by skipping maybe even 4. Yeah, it doesn't have to be super accurate, right? Yeah. We can do it like this. Yeah, this should make it already a lot cheaper. Yeah. And then yeah, how about here we say how about we figure out right. Kalkviz, was ist der? Kalkviz, check. Overlap. Frustum. Yeah. xy. The problem here is, how do we deal? So, what if we could detect that? If we could detect that we can't get a valid intersection, calculus. Overlap tests. Calculus. Equal check. White step. Is there any trick I can do here to detect that overlap will not be possible? Yeah. Overlap is not possible. Overlap. Outside. Overlaps. view plane. Set min, set max. Max. Hmm. Let's take this code and put it here. We still have this mystery here. Yeah. It's max. Max X. Max X is larger than this. It's capped. Oh boy. Oh boy. Crash. Oops. Oh. There we go. So the idea I'm trying to follow now is use the EA code for when the top view plane can intersect with the terrain at a reasonable angle. Otherwise, use our approximation. That's my current thinking here. But for that, we need to detect. Let me do okay, this, okay. Min X 332 341 max. Okay. All right. That's bogus. One 39. Why are these doubles? Yeah. What is this? That doesn't make much sense. Why is it doing this here? Find out why values go out of range. X, min X. X. Yeah, so my suspicion here is that we put this here, say max y, this, and then we also remove the double here. And then also this one here, get field of view is not 0. Why is this there? Get field of view. Do we need this here? Get field of view. M4. Ugh. Let's see. Oh, this does actually hit. So it was always this anyway. Well, that's stupid. So M4 is, yeah, is not 0. Is there ever a case when this guy is not 0? Is 0. Let me see. Well, it's set on init. Set view plane. To me, you know, it looks like to me that we can just remove all of this bullshit here, and we just do that. Boom, done. This is probably effectively the same shit. Okay, and then we do that. Do that. Okay. Okay, and then we say, so camera. Camera class. Get view plane. Get view plane. View plane. Horizontal, vertical aspect. custom class. Top. Normal of the plane. Distance along the normal from the origin. I suspect what we can do is, so we have this plane normal, and then we can make a dot product with a forward normal. With a forward, and then forward. Let me see. So a camera. So camera plane get custom planes. Planes. So the top one, plane 3. Then we do here 3. Then we have a plane class, top plane, top camera plane. Okay. Then we do a top plane n dot product with look at vector. I would say we do I think we can just look at vector. The camera the look at vector, we could take the XY component and then normalize it. That would be useful, maybe. I wonder if we can take it from anywhere else. Camera location. Z rotation. Okay, let's just do look at XY, vector 3. Let's do, yeah, look at XY. And we construct it with look at vector dot x dot y and 0. And then we normalize it. Then we do dot product, and that returns. Oh, it's a static function. Front. Okay, let's do vector 3 dot product. So that will be real. How do we call it? Just call it dot for now. Yeah. So that will be void dots. Okay, let me put a breakpoint here. So the idea is that we sample the top camera plane to a dot product with look at XY, and we figure out the difference, and if it surpasses the threshold, aka looking too close to the terrain, then we don't use this code path. Yeah. So if you look at this here, dot is dot 038. So 0. What was a dot? If they look in the same direction, it's 1, right? Opposite direction -1. Otherwise, if they are 90-degree angle, then it's 0, right? So we should say if it is, yeah, if it is larger than say if dot is larger than 0.05 f, yeah, just some threshold there. Then we do the original code, yeah. Okay, and then else. Else we do this here. But this is not correct. Hold on. Let's say if it is larger. We should probably. I don't think the dot product here helps us this value check because 0. If we are yeah, that's wrong. That's wrong. If we are looking near 1, if it's larger than Okay, let me ask ChatGPT. I'm too stupid for this. Given the top frustum, given the top frustum plane normal, the top frustum plane normal and the terrain XY view direction. How do we calculate the angle to determine the determine the relationship? How do we calculate the angle? Top frustum plane normal should be normalized. Dot clamp. Ugh. Clamp. Dot clamp angle. Arc cos. Normal dot v. Arcsin. Between the plane and the direction. The angle between the direction and the plane itself. Plane angle. For top frustum plane, the normal usually points downward and inwards. If your angle seems inverted, flip the normal. Device input. Angle between normal and direction. Theta, plane angle. Let me take a look at this shit. ACOS WMath clamp. Let's see. So dot is 3.8, okay. Theta is that. Okay, oh, this is all in radians. So at which point? So here the camera is the top plane is close to the terrain, right? So let's put a breakpoint here. 1.5 0. Plane angle. So this is 90 degrees, right? Theta. Plane angle. So what we can do here is we write this as rad to degree F, and this is 90. Yeah. So this is plane. So top camera plane. Let's call this camera top plane. Camera top plane dots. Then we have camera top plane angle. Then we save top plane angle is smaller than 0 dots. Let's say smaller than red 2 degree F 0, I don't know, 1 degree. Maybe 5 degrees. Huh? Okay. Maybe we can do here plane dot equals clamp. Put that step here. Then we put this here. Okay, so that is angle is whoa. Oh, it's degrees. Deck to red F. But I'm not sure if this is correct. So minus 2, 5. Well, that didn't work. 0.39, okay. So top down is 1.36. Oh, that is unexpected value. 0.97. That's 1, 0, 2, 1.36. Okay. Okay, well it's close to 90 degrees. Okay, let's say it's small. Okay, so what happens if we rotate the other way around? So we go like this. Like this. So that looks pretty small. 0.09. Okay. Okay, let's put it in here as long as it's larger than this. Hmm. Okay, so. Okay, that I don't fully understand right now here. So it's already bad at, I don't know, terrain heights, pitch. But it's probably only so bad because we are so... Oh boy. Well, that looks pretty bad. Man, why is it so shitty? My gosh. So this is now still going into this branch, right? Yeah. looks pretty bad. uh. Yeah. Okay, how about so this doesn't really help. This shit here. I don't know, how about we just make the condition this we just use this here. Okay, and then down here we can probably remove this. Then here we just use some magic value, 0.5 for example. Yeah. Yeah. Let's change the resolution. Looks like I forgot something. Yeah, this. Okay, let's sell this. Okay, so this now uses the original calculation, and this now uses okay, that doesn't look good. Let's change that to 25 again. Great. Good. So, yeah, so this looks fine. Yeah. So basically we now combine the two worlds. The original shit the new shit. Yeah. So this should give us here. Okay, looks pretty good. Yeah. Okay. Yeah, then how about we do that? So for all camera pitches above 37, we use the legacy, the original implementation, plus small optimizations that I added there. And then for the low angle, we increase viewable map area here to this draw width. And then we use our very fast approximation. Yeah, I think this will work. Yeah. Yeah. It's not perfect either, but I think for the current use cases we have, I think this is probably good enough for now. Yeah. Someone who has a better understanding can maybe improve this more, but yeah, I think maybe it's a good start for now. Okay. Yeah. Then this means we need to indent this code here. Yeah. Then we remove this and this. Yeah. Oh, that's not great. Looks pretty bad. It's weird that it goes towards the center like that. Okay, cool. Yeah, can do that. Yeah. Good. Then I think what we need to do is put this down here. Then delete all this. Then we take this guy and we put it down here. Then we take this and we put it here. Then we take this and put it there. Set offset, where is this used? There. We take this and we put it here. Okay, good. Then, yeah, we probably need to add some more descriptions here to help understand what's going on there. Okay. Good. Good, I think we can live with that implementation for now. What it does fix now is the weird behavior on low pitch with a height map. Ah, there was one more thing, right? So I wanted to test what happens if we do... What happens if we do... If we take this here... What happens if we take this? And then here we take this. And then this. And then we take max y, min y. How does this look? Don't see much difference there. Okay. Anyway, it's already what the original does anyway, so we don't care. Good, we just remove this again and we keep this. Yeah, it's not the, this code is not ideal either. This code is still shit, but it is the original behavior, so at least we're not breaking anything. It works much better well, a bit better than this code for the regular pitch with the normal draw width and draw height, and yeah, it's a bit more expensive, but it has more accuracy, so you see less of the black spaces on the terrain, so that's good. Yeah, I think I'm happy with this for now. Yeah, it's not ideal, but it's not worse than the original implementation. Yeah. Okay, cool. I think we have now all the building blocks. Now there's still an open question about the world builder. It probably won't compile with the changes we did to height map. So that needs some testing. Yeah. Oh boy. Oh boy. Good. It looks promising. Then then I think I will take a break here. Has been 2 hours. Maybe look at the reviews one time. There have been some updates here. Let's see. Not 0. Okay, that looks better. Okay, template ID +1. Okay, that looks good. Okay, cool. Okay, cool. Okay, cool. Good that we come to an agreement here. Avoid mismatches after loading custom map. Okay, let's look over the code one more time. Template ID. Next template ID is unexpected. Get template ID equals next template ID +1. Next template ID is unexpected. ID equals, if not next, or template ID next T. Next T. Next template. Is this assert correct? Template ID. IDs. This is mistake, right? what did he do? Refactor. Sorry, what? Okay. Good, so run these checks. Yeah, this fucking across its series. Instead of this card. In addition to or instead of this card. Setting mpref 0 in addition to setting mpref will still be necessary for drawable CPP, xfer version 7 for xfer version 7. But not for version 8. New version. Not for new version 8. But please first test it. It was just an assumption on my end. Reading the code. The relevant code. Good. Let's look at this here. Hash. We have a template map. Okay. No. No, that's not safe. No. No. I can already see that this is not safe. Yeah, don't put commented code here. No. What is he doing? What is he? Okay, so he puts a Okay, I actually it's the vector doesn't own the instance. Okay, it's actually okay. The vector is also just containing pointers. Okay, that's fair enough. Okay. Remove commented code. Remove the commented code. This is redundant. This is redundant. You know what? This is malformed. Double delete. Iteration must only happen once. I see now that Let's see that the vector also just owns pointers. Also just owns pointers. The vector also just owns using the vector. Several times in this change. Since we now have a vector plus map, I suggest to revert this to clarifying that these containers point to the same pointers, but the map is used for name key lookups. Name key lookups only. So something I would write it as something like now additionally stores weapon templates in a hash map to optimize lookups. Now additionally. Optimize name key lookups. Lookups by name key. Still is the same. Put blank line after this for separation. Blank line after this for separation. Yeah, so I don't know. I don't know why he does it twice now. That's wild. Yeah, that shouldn't happen. You still need to push back. Still needs to push back to vector, otherwise it stays empty. The idea is to use the vector for iterations only, use the unordered map, hash map, use a hash map for name key lookups. Both containers point to the same data. Yeah, to me it looks like he did not really understand what I asked him. He kind of did it, but not quite right. But it's close. It's almost there. Okay. 5 new comments. Let's go. Should probably say that these containers hold the same pointers. Good. Needs review, yeah. Okay, he did finish this. Yeah, okay. I think he also did that, probably. Common format, and he fixed that as well, yeah. Okay. Good. Don't have Identica. Let me see this. Yes, should be, because the changes are made resulted in the same ID value for the templates themselves, just a different starting point. Yes, should be. Okay. Okay, well, if he says so, let's try to wrap our heads around this. Get template ID, so that's a current one. The current template, and then the next. So this is the current, this is the override, yeah. Get template ID, template hash map, temp, and then it equals the next template ID plus 1. Get template ID equals template ID plus 1. I don't quite understand why this is correct. Let's look at the change again. He says should be. So he's not sure, according to this wording here. It looks weird. Like I would have expected like this template ID plus 1 equals next template ID, right? Like T. What is T? Let me see. T. T's first template. What is next? Next, get next template. T itself can be deleted, reset. T first template. Delete any overrides. Delete overrides. T template ID. So it's just that. Okay, so it's just to verify that the templates have a so there's a linked list. It's a single linked list between the templates. It always points to a next template. Yeah, and this assert just verifies that they have a linear ID, right, without gaps. Yeah, okay, that makes sense. Okay, makes sense. Okay, then that's cool. Yeah. Avoid mismatches by making unique for a single match instead of unique since game launch. Okay. Next template ID. Get template ID. Static casts. Static cast is not needed. This already is short. Next template ID. Reset. Okay. Okay. Let's look at this here one more time. 6, 7, 8. Removed. 7, 8. This here. I don't think it's necessary to check if all status equals. Yeah, I agree with that. I think I don't agree with this stuff here though. This needs removing. Version smaller equals 7 and load. Man, have to do everything yourself. You have to do everything yourself. There we go. There we go. It should be like this. Then here you can say this is bug fix. Trigger. Swagger's add bug fix. Okay, then we can resolve this, and yeah, there's still more to do here. This needs removing because loading version 7 save game still needs handling regardless of okay. Good. Nineteen six three. Well, not now. I wanted to take a break half an hour ago. I will do it now. Good. Then, yeah, time for a break. I wish you a great day or night. Until next time. Goodbye.